Today we need to start looking at how to pull information off of a graph, and by that I mean if you look at these questions, you'll kind of see that I don't mean there's a graph, tell me like stuff we might have talked about in algebra or geometry. We're now tying function notation into our questions, so we have to become fluent in function notation, be able to navigate what that means, understand what that means. It's not difficult, it's just you have to be willing to learn this, right? So there's the way we always have thought about it before we start getting more formal. Usually, especially if you don't think you're going to be like a mathematician, you kind of resist trying to get more formal in your writing and your understanding. But if we want to keep progressing, you've got to start upping the way in which you can talk about mathematics, because it does get increasingly more abstract and complex. So this is going to be necessary moving forward. So here I have a function. You can see each tick mark is 1 unit, so we'll just have to count it off as we go. When you do problems, you'll see a nice graph on a coordinate axis that you can read all the coordinates well. So let's look at number 1. So what does it mean, like if I said find, and it says f of 0 equals what? Well, let's backtrack for a minute. Do you remember back before you'd have y equals like, let's say it could be anything, like 2x plus 1, but let's make it really simple. Let's say we had y equals x, right? Well, there came a time, I don't know, that might be confusing. Let's keep it like this. There was a day when all there was y's. And then at some point, a teacher said, instead of thinking about y, let's change that to f of x, right? And there's good reasons to do that. Doesn't seem like it at first, but the deeper you go, you start to realize there's value in doing this. You're probably not quite there yet. Well, look at what this is saying. Focus on this part of the equation. If you can like interchange these, right? If I can replace y with f of x, that means y is the same as f of x, right? And see what this is asking. See this question right here? This is probably not, it's true, but probably not helpful. This question right here, right, if I put a 0 in here, what does that even mean? Let's make one of those a negative. Let's make that minus 3. See how there's extra information here, right? These all just say y, but here these numbers are changing. That's one of the reasons to go to f of x notation, because it has extra information. What this means is, what is y when x is 0? See, this is the x slot. See how that's in the x slot? So this is saying, what is the y value? I don't like how that probably looks to you. Let's get rid of this. The whole f of x is the y. The whole f of x is the y. So when I say, what does this equal? What does this equal? What does this equal? What does this equal? This is the y value you get when x is 0. See, 0's in the x slot. What goes in the y slot? When minus 3 is in the x slot, what goes in the y slot? This one is asking the question, what is y when x is minus 3? See how that's in the x slot? If we can start to understand, when I see this question, I think those thoughts, then this is easy. If you don't understand what that's saying, then you just won't get this. What is y when x is 0? This is f of x. When x is 0, what is y? Well, when x is 0, if I go up to my curve, 1, 2, 3, 4, 5, 6, not quite 7. See that? I'm going to say 6.8. If you said 6.9, that's fine. If you said 6.7, that's fine. I think it's pretty clearly just a smidge under the 7. If you said 7, I might take off a quarter point for that, just a little bit. But that's the idea. Y is about 6.8 when x is 0. What is this saying? What is y when x is minus 3? So I find x is minus 3, 1, 2, 3, and I go up to the y value, and that looks like it's at 2, right? When x is minus 3, it looks like when x is minus 3, the y value is 2. What is y when x is 5? So I go 1, 2, 3, 4, 5. I go straight up to find the point that has x value of 5. And I want to know, see, that's 5 over. I want to know how high up that is. So I would look across here. And that looks just a shade under, remember this was 6, 7, 8, 9. To me that looks just a shade under 9. I'm not quite level with this. Let's call that, I don't know, 9.6. No, 8.6. We're not quite to the 9. Right? So you see what's going on there? Where this is telling us where to look on the x-axis, and we're supposed to say what the y value would be when you go to that point on that curve. Let's look at this one. We're switching gears here. Find x values such that f of x, or y, equals 3. Find the x's where the y would be 3. Well, where is the 3? Right here. Right? There is where y equals 3, that high. So we got to find the x values. There's 3 of them. This curve called f of x, this f of x, that is this picture. It hits that height here, here, and here. So I have to give the x values for that. So what I'm going to do is I'm going to drop straight down and find the x coordinate here. I'm going to find the x coordinate here. I'm going to find the x coordinate here. So I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's call it 11.3. Minus 11.3, comma, because that's not the only one. I'll put x equals. This one was at 1, let's call it 2.1, negative. And there was another one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 3 places where that curve is 3 units high. That's what this is saying. When y equals 3, y is the vertical variable. When y is 3, that would be this height, and the curve hits it there, there, and there. Give me the x, give me the x, give me the x. You know what? We'll worry about this another day. Find the x values such that y is less than 1. Well, what that means is find all the places where this curve is below y equals 1. Well, that would be here. So this curve is below y equals 1 from here to here. it's above it all. Let me get rid of this one. Starting to get a lot of clutter here. Find the x values that's along this axis such that y is less than 1. So here's y equals 1. I want to show everywhere the curve is lower than that, less than y equals 1. Do you see how it's going to be this piece right here and this piece right there? Literally the stuff below y equals 1. If you can see it, all you got to learn is how to say it. We're looking for the x values. Right? Here's where the ruler was. So that would be from here to here. So that would be from 1, 2, 3. Erase my tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is minus 10 and a half. 1, 2, 3. Let's call it minus 4. I kind of lost my tick mark. So let's say this is at minus 4 and this is minus 10 and a half. See that? It's below the x-axis from minus 10 and a half on the left to minus 4 on the right. So that would be minus 10.5 to minus 4. X is more than, think of the alligator teeth, x is more than that on this side and also less than that. Another way to look at it is x is sandwiched between minus 4 and minus 10 and a half. Well, that would cover this part. How about this part? Well, this starts to be below right there, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is also, so I'm going to put, or x is greater than 14. That is everywhere where the line, that curve, is below the y equals, I said that really badly. This lists everywhere that the curve is less than 1, where the y values are less than 1, where the curve exists below y equals 1. All right? I know, see, it's very visual. It's the key is seeing this and understanding that visual, right? It's very obvious to say, point to me the stuff below that line. It is another matter entirely to know that these words mean what I just said to you, because they are the same thing. See, we're trying to learn how to speak math. Everybody, I could bring a third grader up here and say, point to me the stuff below the line. But it takes someone like you to learn that these words mean what I just said, right? So we've got to try to understand this language. So I'm going to add a little bit of complexity here because, you know, you can go back and rewind and try to watch it again, or we can talk further about what's going on here. Kind of lost that tick mark. Now, sometimes what happens is they throw another curve on there. So let's do something like this. I hope that's a different enough color. Let me try red in case that doesn't stand out enough on the screen. Yeah, I think that's a little better. See, now what's going on here, now we're going to start to see a little bit of what this f of x and g of x means. What does that mean? What if there are multiple curves on the same graph? How am I supposed to tell one from another? Like, if I'm standing here and I don't point and I say, I want you to look at f of x, how are you supposed to know which ones I'm talking about? See, one of the functions, I'm going to give a name with a letter, we'll call it f of x. And to tell them apart so I can do it verbally, I'm going to call this other one g of x. So now if I say, look at the curve, you wouldn't know which one I meant because there's two of them. But if I said, look at g of x, you should be looking at the red one, right? Because I named it, so you know where to look. Well, look at what I wrote up here again. All of the questions I wrote were about f of x because that was all that was on the board. What if I start asking you stuff like this? Number 4. What's g of 0? What's g of minus 3? What's g of 5? Find the x values such that g of x is equal to 3. Well, now what do I do? See, I'm thinking the same thoughts. See, this is for the same x value. That hasn't changed. But the curve I'm looking at has changed. So now to answer this question, to answer this one, I looked at the purple and I said, when x is 0, what is y? When it says, what's g of x, I look at the red. And when x is 0, what is y? I'd say that's about 1.5. See, two different curves, but it's at the same x value. They're both right on the y-axis. So I have a way of saying, tell me this curve when x is 0 and this curve when x is 0. See, this is one of the reasons we use function notation instead of just y all the time, because it gets more complex. What's g of minus 3? Well, I find minus 3, and I'm looking for g. G would be the red one. So I got to go up to here. And that looks like it's about, let's call it 4. And g of 5, well, I go forward to 1, 2, 3, 4, 5. And instead of going up to f, I go down to g. And I look over, and that looks like about minus 1. Right? Because at x equals 5, the y would be minus 1. All right, well, what did I do with the number 3 up here? I found the value where y equals 3. And these are going to be pretty close, aren't they? So when y is 3 on the red curve, see, all this notation, that's what it's telling you. What is y on the red curve, g, when... I'm sorry. What is x? What is x on the red curve g when the y value is 3? This whole thing is like a y value. Oh, I'm sorry, I said that really badly. Find x on the red curve g when the y equals 3, when the whole package equals 3. Well, that would be at x value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right around that 10.5 mark. X equals minus 10.5. About minus 1.5. Right? Here's the red one hitting the 3 level, and I drop down and I see it's around the minus 1.5 mark. And then here's one. The red curve, G, is hitting y equals 3 right about here. 4, 5, 6, 7, 8, 9, 10, 11. Let's call it 11.7. So look how similar the questions are. And now we can start to see that, right, what this is telling us, what the letter in the f of x, the f, and what does the g mean, and a little bit of how the x's work. I don't know. I hope this is at least clicking a little bit. Another thing I can ask when there are multiple graphs up here, multiple curves, is I could ask you things like this. So we're on question 5. Let's call it question 6. where does f of x equal g of x? Now, when we say where in this context, that means for what x values are f and g the same? Well, here comes a very important thing to know. F and g are the same when they cross each other, right? When the purple curve comes into contact with the red curve, at that specific moment, they are equal to each other because they share the same coordinate. They go through the same point. The same. They're at the same spot. The functions are the same as each other, not all the time. They're doing all kinds of different things, but at that one spot, they're in agreement. Also at this one spot and this one spot. So that's an important idea. Curves are equal where they intersect. And of course the word intersect means kind of cross each other. So I should be getting 3 answers for this, 3 x values for where those things cross. For what x? For what x values does f of x equal g of x? Right? The height of f is the same as the height of g. I can't help but want to say that as we move into calculus. This is true pre-calculus thought here. As we move into calculus, this statement right here means this thought. At what horizontal locations is the vertical location of these 2 curves the same? That is what we're asking here. And that would be here and here and here. So let's call that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.3. Looks like right on the -2. And if that was 14, that's 13 and 12. So let's say 12.6. Right? If you say 12.5 or 12.7, that's fine. But these are reasonable x values. So where is this true? X equals -11.3, x equals -2, or x equals 12.6. So where are they equal? Where they cross. Where are they equal? Where they cross. One more thing, and then I got to erase, and then we'll tie this lesson up. A last thing I could do is I could ask you, I'm on question 7, for what x, for what values of x, is f of x greater than g of x? Now that literally means, where is f higher than g? Because greater means bigger. If this was less than, I would say, where is f lower than g? And it's very visual. F is bigger than g, literally everywhere the purple is higher than the red. See, now, sometimes you got to know how to look at a graph. You see this x-axis? Where is the purple above the red? Back in that chunk of the graph, the purple is above the red. In that chunk of the graph, the purple is above the red. Here, no. Here, no. See how it's kind of a left to right kind of analysis? where on the curve, what chunks of the curve is the purple bigger than the red? The purple bigger than, higher up than the red, G. Well, that would be everywhere behind that X is 11.3. Everywhere behind that X value. So I would say for X's less than minus 11.3, or for any X between these two lines. Well, let's turn that into math. X is between minus 2, as low as minus 2, less than, right? As low as minus 2, but no bigger than 12.6. So everywhere X, where, for what X's is F bigger than G? Everywhere behind the 11.3 or everywhere between the minus 2 and the 12.6, right? If I had said where is it greater than or equal to, then that would just include these border points. That would be the only difference. All right, I'm going to try to let you hash this out with some practice problems. It's very visual. You're just getting used to what this notation is saying and learning how to decipher it. So play with it. Ask me questions if you're not clear.